Given question, the charter trip is restricted to 200 persons. The following table summarizes the estimated prices for the three packages and the corresponding expenses for the travel agent. The travel agent has hired an aircraft for the flat fee of rupees 2 lakh for the entire trip. In planning the trip, the following considerations must be taken into account. First, at least 10% of the packages must be deluxe type. Second, at least 35% but not more than 70% must be of the standard type. Third, at least 30% must be of economy type. Fourth, the maximum number of deluxe packages available in any aircraft is restricted to 60. Fifth, the hotel desires that at least 120 of the tourists should be on the deluxe and standard packages together. The travel agent wishes to determine the number of packages to offer in each type so as to maximize the total profit. First question, formulate the above as a linear programming problem. Second, restate the above linear programming problem in terms of two decision variables, taking advantage of the fact that 200 package will be sold. Third, find the optimum solution using graphical method for the restated linear programming problem and interpret your results. This question was asked Dayalbagh Education Institute, Agra, MBA 2005, Delhi University, MBA 2004.
Let us understand given data. Persons allowed for trip 200. This table is mentioned in the question. Now tour plan. There are three types of tour plan: deluxe, standard and economy. For each plan, there are the different prices that the company will get from the persons. And there are different costs, that is the hotel cost as well as meal cost that the company have to pay for per person. There is one more information, aircraft fee, that the company have to pay rupees 2 lakh for entire trip. Now let us first formulate the given information. For that we will consider x1 number of persons for the deluxe tour plan, x2 number of persons for standard tour plan, x3 number of persons for economy tour plan. Now if we observe total persons allowed is 200. So we can write here x1 plus x2 plus x3, that is equal to 200. Now we are going to solve this question by using graphical method. Now in graphical method we know that on horizontal line we have to plot the values for x1 and on vertical line we have to plot the values for x2. Now here we have to convert this x3 in terms of x1 and x2. So how I can write here? I can write x3 is equal to 200 minus x1 minus x2. So this x1 plus x2 I have to shift to the right hand side. Now we will calculate the profit. So for each tour plan, how to calculate profit? That is price minus hotel cost minus meal cost. So I will add all this profit from the deluxe plan, standard plan and economy plan. So here maximize profit Z is equal to, I will write here 10,000 minus 3,000 minus 4750. Now we have to multiply with number of persons, that is x1 plus. Now we will take the standard plan, that is 7,000 minus 2,200 minus 2,500 multiplied by x2 plus. Now we will take the third plan, that is 6,500 minus 1,900 minus 2,200 multiplied by x3. Now this is the profit from each plan. But here rupees 2 lakh that company have to pay as a aircraft fee. So we have to subtract this 2 lakh also. Now we will simplify this. So we can simplify this, or we will solve this bracket. So here 10,000 minus 3,000, that is 7,000 minus 4750, that is 2250x1, plus, now we will solve this 7,000 minus 2200 minus 2500, that is 2300 x2, plus 6500 minus 1900 minus 2200, that is 2400 x3, bracket complete, minus 2 lakh. So this is the maximize profit Z. So I will write here Z is equal to, because this is the simplified equation. Now we know that we have to put the value of x3, that is 200 minus x1 minus x2. When we simplify this, 2250 x1 plus 2300 x2 plus 2400 in bracket 200 minus x1 minus x2 minus 2 lakh, then we will get the equation in the form of x1 and x2, that is minus 150 x1 minus 100 x2 plus 2 lakh 80,000. Now if we observe, this is the objective to maximize profit Z. Now we will move to the constraint. So first constraint is given, at least 10% package must be deluxe type. So all the package, that is the number of persons, x1 plus x2 plus x3. So from all the packages, number of persons from the deluxe type, that is x1, should be greater than or equal to 10%. So 10%, that means 10 by 100, and which is equal to 0.1, or we can write 0.10. So how we will write this, that is x1 divided by x1 plus x2 plus x3 should be greater than or equal to 0.10. Now we will transfer this denominator to the right hand side. Then we will get x1 is greater than or equal to 0.10 x1 plus 0.10 x2 plus 0.10 x3. Now we will simplify this. So how to simplify this? I will transfer this whole right hand side to the left hand side. Then here will be, here coefficient of x1 is 1 and here coefficient of x1 is 0.10. So here if I transfer this whole term to the left hand side, then it will get the minus sign or negative sign. So 1 minus 0.10, that is 0.9 x1 minus 0.1 x2 minus 0.1 x3 should be greater than or equal to 0. Now again we will simplify this by multiplying 10. Then 9x1 minus x2 minus x3 should be greater than or equal to 0. Now we have to replace this x3, because we have to write the value of x3 in terms of x1 and x2. So x3 we have to put in bracket 200 minus x1 minus x2. Now if I multiply this minus sign inside the bracket, then it will become minus 200 plus x1 plus x2. Now again we will simplify this. So this minus x2 plus x2 is getting cancelled. Now here 9x1 plus x1, that is 10x1 minus 200 is greater than or equal to 0, and therefore x1 is greater than or equal to 20. So this is our first constraint that is useful to draw the graph. Now we will move to the second constraint. At least 35% but not more than 70% must be standard type. So here for standard type, that is the number of persons x2 percentage is given at least 35%, that is x2 percentage that is equal to or more than 35 but not more than 70, that is it is equal to 70% or less than 70%. So we have to write here two types, that is x2 divided by x1 plus x2 plus x3, that is more than or equal to 0.35. And for this 70% condition, we have to write x2 divided by x1 plus x2 plus x3 is less than or equal to 70%, that is 0.70. Now we will simplify this. We will transfer this denominator to the right hand side for the both cases, and this sign less than or equal to, or here more than or equal to, remains same. Now if we observe, we have to simplify this. So we will take this right hand side to the left hand side in both cases. So here this plus sign will become minus. So how we can write here? X2 minus 0.35 x1 minus 0.35 x2 minus 0.35 x3 greater than or equal to 0. Now in the same way here it will become x2 minus 0.7 x1 minus 0.7 x2 minus 0.7 x3 is less than or equal to 0. Now we will simplify this. So if I multiply here with 100 and here also with 10, then we have to write these equations. Then if we observe, here is 35 and 65, we can divide the 5. So minus 7x1 plus 13x2 minus 7. Now instead of x3 we will write 200 minus x1 minus x2. And now we will multiply this 7 with inside the bracket, and this minus sign we will also multiply inside the bracket. And when we simplify this, then we will get x2 is greater than or equal to 70. Now in the same way we have to repeat the same process. So here minus 7x1 plus 3x2 minus 7 in bracket 200 minus x1 minus x2 is less than or equal to 0. So when we simplify this, we will get x2 is less than or equal to 140. So these are the two constraints, that is x2 is greater than or equal to 70 as well as x2 is less than or equal to 140. These two constraints are useful for this graphical method. Now we will move to the next constraint. At least 30% must be economy type. That is minimum of 30% is required. So we can write here, that is how to write this economy type percentage. So out of the total, that is x1 plus x2 plus x3, economy type is x3. So x3 divided by x1 plus x2 plus x3 is greater than or equal to 0.30. Now we will simplify this. I will transfer this denominator to the right hand side and multiply with 0.3. Now on both sides, if I multiply with 10, then it will become 10x3 is greater than or equal to 3x1 plus 3x2 plus 3x3. Now I will transfer this right hand side to the left hand side. So it will become minus 3x1 minus 3x2. Now 10 minus 3, that is 7x3 is greater than or equal to 0. Now instead of x3 we will put the value in terms of x1 and x2, that is 200 minus x1 minus x2. Then we have to multiply this 7 inside the bracket, then simplify this, then we will get x1 plus x2 is less than or equal to 140. So this is the equation that is useful to draw the graphical method. Now we will move to the next, that is next constraint. Maximum number of deluxe package in aircraft is restricted to 60. That is, we cannot extend this package over this 60. So we can write here as a x1 should be less than or equal to 60 because of this aircraft constraint. Now in hotel, at least 122 days should be deluxe and standard type. So deluxe and standard type, that is x1 and x2. So this x1 and x2, that is equal to at least 120. So minimum 120 or more than that. So how we will write? x1 plus x2 is greater than or equal to 120. Now we will find out the optimal solution by using graphical method. If we observe, these are the constraints. Now to use the graphical method, we have to prepare here one table. First column is constraints. So to write these constraints, we have to write as greater than sign or less than sign in terms of is equal to sign. That is, for the first constraint we will write x1 is equal to 0. For second constraint, I will write x2 is equal to 70 as well as x2 is equal to 140. Now why to write this constraint? to plot the points on the horizontal line as well as vertical line. So the next column is for x-axis. So on x-axis we have to plot the values of x1, and for that purpose we have to put the value x2 is equal to 0. Now these points, that is for the values of x1, that is 20, 140, 60, 120, we have to plot on the x-axis. Then the next column is for y-axis. So on y-axis we have to plot the values of x2, and that's why we have to put x1 is equal to 0. So if we observe, we have to plot here x2 value, that is 70, 140 and 120. Now if we observe these values on the x-axis as well as y-axis, that are varying from this 20 to 140. So we have to take equal distance. So you can take here 1 centimeter, 2 centimeter as per the space available, and we have to start from 0 and we have to end up to 140, because maximum value is 140 on x-axis as well as y-axis. So I will take here 0, 20, 40, 60, 80, 100, 120, 140 on both the lines, that is on horizontal line as well as vertical line. Now in this case all the values are positive. So this is the first quadrant, because if we observe on the x-axis, on this opposite side here is 0 and opposite side there are negative values. In the same way on y-axis, this downside for this 0 there are the negative values, but here no any negative value is there. So I have taken here this first quadrant. Now we will assign the points. Now for the first, if we observe for the first constraint, x1 is equal to 20. So this is the line for x1. So x1 is equal to 20. So from this line I will draw here one vertical line. Now if we observe, this x1 is given is greater than or equal to 20. So for this line I will write here x1 is greater than or equal to 20 and the value is greater than 20. So I have to show arrow towards the right hand side, because all the values, that is it may be 30, 40 and so on. Now we will move next. So x2 is greater than or equal to 70. So here x2 is 70 and x2 is 140. So we have to first draw the lines. Now here is the 70. So 70 is in between the 60 and 80. So we have to assign here middle point, and I will write here 70 also, and we will draw here one horizontal line. So this is the line for x2 is equal to 70. Then x2 is equal to 140. So here is 140. So I will draw here one line. Now we will move for the constraint. So constraint is x2 is greater than or equal to 70. So I will write here x2 is greater than or equal to 70. Now we have to show arrow. So greater value 70, that is 80, that is in the upward direction. So we have to show arrow in the upward direction. Now here x2 is less than or equal to 140. So this is the line for x2 is less than or equal to 140. So less value, that means the values in the downward direction. So we have to show values in the downward direction. Now we will move next, that is the third constraint. So for this third constraint, x1 is 140 and x2 is 140. So we will assign the point. So x1 is 140 here and x2 is 140 here. So we will join this or connect this point. Now for this line we have to write here the equation, that is x1 plus x2 is less than or equal to 140. So now these 2 points are connected. Now the values are less. So less values, that means on this horizontal line here is 120, 100, and on this vertical line here in the downwards direction, that is it may be 120, 100. So we have to show arrow in the downward direction, that is in this direction. So we have to consider all the space. Now we will move next. So next constraint, x1 is equal to 60. So how to draw the line? So here for x1 is equal to 60, I will draw here vertical line. Now for this vertical line, if we observe x1 is less than or equal to 60. So I will first write here x1 is less than or equal to 60. So all the values for the x1 are less. So I will assign here the arrow in this direction. That is in the backward direction, because if we observe here is 50, 40 and so on. Now we will move for the next, that is x1 plus x2 is equal to 120. So in this case we have to take here this 120 as well as 120. So we will select these 2 points and we have to join these 2 points. So we will join these 2 points. Now for this line we will write here x1 plus x2 is greater than or equal to. So I will write x1 plus x2 is greater than or equal to 120. So for this line, greater values, that is on x-axis to the right hand side and on y-axis in the upward direction. So I will show arrow in the opposite direction, that is in the upward direction. Now we have to highlight the area. So how to highlight the area? So here we have to consider this strip, that is these are the 2 parallel lines. So above this line and below this line we have to consider the area. Now if we observe, here is the vertical line. So for this vertical line we have to consider the area to the left hand side, and for this line we have to consider the area towards the right hand side. So I will highlight the area. So I will highlight all these points. Now this is the line. So here I will consider this point. Then here, because after that we should not consider this area. So I will consider this point also. And here is the point. So if we observe here x2 is greater than or equal to 70. So we have to consider the area above this line. So here is 1 point and here is also 1 point. So if we give here the letters, then I will give here is the letter A, then here is the letter B, here is the letter C, here is D and here is E. So this is the area that we have to consider. How to find out the optimal solution? This is the objective. We have to maximize the value of z minus 150 x1 minus 100 x2 plus 2,80,000. Now if we observe, here are the points A, B, C, D, E and we have to find out the coordinate. So to find out the answer, we will prepare here one table. First column for points, second column for coordinates. So what are the coordinates for A? So for A it is 20. So we have to write the value on x-axis and then value on y-axis, that is 20 and 120. So I will write here 20, 120. For B it is 60, 80. Then for C it is 60, 70. Then for D it is 50, 70. Then for E it is 20, 100. So these are the coordinates. Now we have to find out the value of z. So for this first value, that is on x-axis, that is the value of x1. So how to find out z value at point A? That is 20 multiplied by minus 150 minus 100 multiplied by 120 plus 2,80,000. Now in the same way for second value, this first value is for the x1 and this second value is for x2. So we will write minus 150 into 60 minus 100 into 80 plus 2,80,000. Then the third, minus 150 into 60 minus 100 into 70 plus 2,80,000. So in this way we have to calculate the value of z. Now if we observe these values, then we have to maximize the profit. That is, we have to select the maximum value, that is 2,67,000. So if we observe, this is the maximum profit that is available at point E. So here is point E. So point E is having x1 value that is equal to 20, then x2 value that is 100, and then what about x3? So x3 is equal to 200 minus 100 plus 20, that is 200 minus 120, so which is equal to 80. So if we observe for the maximum profit, the number of persons for the deluxe plan, that should be equal to 20. Number of persons for the standard plan, that is x2 is equal to 100, and the number of persons for the economy plan, that is equal to 80, and this is the answer.